Welcome students. Let us continue with the topic surface area and volumes. Today we will find the surface area of those solids which are in combined state. For this let us take an example of the combined solid. There is the question which says a solid is in the shape of a cone standing on a hemisphere. Now let us draw a cone. And this cone is standing on a hemisphere, and let us draw the hemisphere. This is the type of solid that has been given in the question. It says that the radii of the conical part and the hemispherical part is 1 centimeter. This is the radius of cone as well as hemisphere, equal to 1 centimeter. And then we are given the height of the cone is equal to its radius. Now, the height of the cone is this one, which is equal to the radius of the cone, and radius of the cone is again 1 centimeter. So, height of the cone is also 1 centimeter. We need to find the volume of solid in terms of pi. Now, we are given, if we start to solve this question, we are given that radius of cone r to be denoted by r and radius of hemisphere is both equal to 1 centimeter each. If radius of cone is denoted by r, we can denote radius of hemisphere with also r, because both are having same magnitude, 1 centimeter, and the height of the conical portion is equal to the radius of the cone, that is also 1 centimeter. We need to find the volume of that solid surface. Now, how can we find the volume? The volume of that solid is equal to the volume of the conical portion plus volume of hemisphere. We know the volume of cone is 1/3 of pi r square h, and volume of hemisphere is 2/3 pi r cube. We are told to find the volume of that solid surface. Its volume is to be found in terms of pi. So, let us take pi r square common in both, and in the brackets it remains 1/3 h plus 2/3 r. Now, pi as it is, r is equal to 1 centimeter, it is 1 square, 1/3 into pi h is again 1, and r is also equal to 1. So, it becomes pi, because 1 square is 1 and 1 into pi is pi. Then we have within brackets 1/3 and 2/3, and from here we write the volume of that solid is equal to pi, and within brackets is 1 plus 2 over 3 becomes pi 3/3, 3 ones, and the volume of that solid is pi centimeter cube. Another question from that exercise. Let us take another similar example from the topic. We are given a vessel is in the form of an inverted cone Let us draw a conical shaped vessel. It is an inverted cone like this. This is the radius of the cone. Its height is 8 centimeters. It is the height of the cone. It is 8 centimeters. And then we are given the radius of its top, which is open, is 5 centimeter. The radius of the cone is 5 centimeter. And it is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 centimeter, we draw a spherical lead shot with radius 0.5 centimeter. When lead shots are dropped into the vessel, 1/4 of the water comes out from the vessel. And we have to find the number of lead shots dropped in that vessel. Let us repeat the question. We are given an inverted conical vessel that is filled with water up to the brim, up to the top. The conical vessel is 5 centimeter in radius and 8 centimeter in height, and as spherical lead shots are dropped into that vessel. The radius of the lead shot is 0.5 centimeters, and when we drop number of lead shots into that vessel, 1/4 of the water or 1/4 of the volume of the water comes out of the vessel. We need to tell how many such type of lead shots have been dropped into the vessel. So, let us start with this. We are given an inverted conical vessel and its radius is 5 centimeter. Radius of conical vessel denoted by R. Let me denote it by R, and it is equal to 5 centimeter. The height of that conical vessel is 8 centimeter. Now, we find the volume of that conical vessel. Volume of conical vessel. Let me denote this volume by V1, and the volume of cone is 1/3 pi r square h. It is 1/3. Keep pi as it is. Now, r is equal to 5 square, and h is 8. So, the volume is 1/3 pi, 5 square is 25 into 8, that is equal to 200/3 pi centimeter cube. The volume of that vessel is 200/3 pi centimeter cube, and the volume of the water in the vessel will be the same as the volume of that conical vessel. So, we can say volume of water in that conical vessel is same as the volume of the vessel, that is 200/3 pi centimeter cube. Now, the next part of the question is the spherical lead shots are dropped into that vessel, and we drop as many lead shots into the vessel so that 1/4 of the volume of the water comes out of the vessel. So, let us find the volume of the spherical lead shot. Radius of the spherical lead shot let me denote it by capital R, is 0.5 centimeters. You can write it as 5/10, 5/1, 5/2, that is 1/2 centimeter. Now, we find the volume of spherical lead shot. And what is the volume of the sphere? It is 4/3 pi r cube. So, inserting the values 4/3 pi as it is, and r is 1 by 2 whole cube. 1 by 2 multiplied thrice by itself is 1 by 8. You can write 4 by 3 pi into 1 by 8. This is 326 pi by 6 centimeter cube is the volume of one lead shot. Now, the question is, we do not know how many lead shots have been dropped in the vessel, but we are given that as many lead shots are dropped into the vessel, 1/4 of the volume of the water comes out. So, we write let number of lead shots dropped be n. So, this situation can be represented in form of an equation like this. So, according to the given condition, pi by 6 is the volume of the lead shot that is dropped into the vessel, and if we drop n number of lead shots in the vessel, the 1/4 of the volume of the conical vessel, the water from that conical vessel comes out. 1/4 of the volume of the conical vessel, that is 200 by 3 pi, this amount of water comes out. So, this equation represents the whole situation. The volume of n number of lead shots when dropped in the conical vessel takes away 1/4 of the volume of the water already in the vessel. So, we can cancel pi, and n is equal to 41450 on cross multiplying. This is 50 into 6 by 3, and n is equal to 100. It means that when you drop 100 lead shots into that vessel, which is filled with the water, the volume, 1/4 of the volume of water comes out. And this is the answer. Hope you understand that question. Now, let us take another example from the same topic. It says a spherical glass vessel has a cylindrical neck, 8 centimeter long, 2 centimeter in diameter. The diameter of the spherical part is 8.5 centimeter. By measuring the amount of water it holds, a child finds its volume to be 345 centimeter cube. We have to check whether the student is correct, and taking the inside measurements and pi equal to 3.14. So, how to be drawn that figure? A spherical glass vessel with a cylindrical neck. This is the type of the vessel. This is the spherical part, and this is the cylindrical part. This is the neck of the bottle. This is the vessel the question is mentioning about. It has a cylindrical neck 8 centimeter long. This is its neck, and it is 8 centimeter long. And then we have, it has a 2 centimeter diameter. That means its radius is 1 centimeter. And the diameter of the spherical part of that vessel or bottle is 8.5 centimeter. This is the diameter. It is 8.5 centimeters. So, we have to find out how much of water it holds. Means that we have to find the volume of that vessel. So, first of all, we will find the volume of the cylindrical part, then we will find the volume of the spherical part, and both adding will give us the volume of that vessel. So, the radius of cylindrical part, that is the neck of the bottle. The radius of the cylindrical neck is 1 centimeter, and the height or length of that cylindrical neck is 8 centimeter. The radius of the spherical part is half of 8.5 centimeter. Spherical portion, we can denote it by R1. It's 8.5 divided by 2, or we can write 85 by 20. On cancellation, it is 517, 54, that is 17 by 4 centimeter. Now, we need to find the volume of that spherical glass vessel. Therefore, volume of this glass vessel. It is the volume of cylindrical part plus volume of spherical part. Now, the volume of cylindrical part, the volume of cylinder is pi r square h, and volume of spherical sphere is 4 by 3 pi r cube, 4 by 3 pi r cube. Now, inserting values in these numerical values in these formulas, we have pi, the common between the two, and within the brackets we have r square h plus 4 by 3 r dash cube or 1 cube. Now, pi is to be taken as 3.14, r is the radius of the cylindrical part, that is 1 into square, and h is 8 plus 4 by 3. R1 is the radius of spherical portion, it is 17 by 4 whole cube. So, 3.14 as it is, 1 square into 8 is 8 plus 4 by 3 into 17 multiplied thrice by itself is 4913, and 4 multiplied thrice by itself is 64. Now, when you cancel 416, it becomes 3.14 into 8 plus 4913 divided by 48. On dividing 4913 with 48, we get it equal to 102.35 approximately. Now, adding 8 to 102.35, it becomes 110.35, and on the product between the two, it is 346.5 centimeter cube approximately. So, the volume of that glass vessel is 346.5 centimeter cube, and it is not 345 centimeter cube as the child has found. Hence, the solution, the volume of the vessel found by the child is not correct. It is actually 346.5 centimeter cube. Hope you understand this type of questions. Thank you.